Morning everyone, just almost afternoon. I hope you've all had a great Unreal Fest, hopefully if you're not too under the weather today. But we've got lots of visuals, no size 8 font, so we should be able to keep you awake for the next 45 to 50 minutes. Thanks for coming to our talk. So we're going to be talking about building immersive real-world digital twins with Unreal, Twinmotion and Cesium. I'm Ryan Veenstra, I'm a Senior Solutions Architect at Cesium. I focus in particular on digital twins and AEC workflows. I've spent the last sort of 18 to 20 years working with real-time 3D tech on big infrastructure projects, road, rail, things like that. Back in the day, Open Scene Graph, Ogre 3D, through to Unity, Unreal, all those sorts of things. And I'll let Greg introduce himself.
Yeah, hello everybody. I'm Greg Demchak with Bentley Systems. I run our emerging technologies division within Bentley Systems. And we test and experiment with new tech as it emerges. And Unreal Engine's been one of those platforms we've been experimenting with, and Cesium in fact. And so it's excited to be kind of going from the lab now into like a full-blown integration. So we're happy to kind of announce that. And we've got a team of UE devs, and we've been working within this space for quite a long time. So, and then this point too, I know we had a lot of conversations in the hallways throughout the conference, and it's exciting. I'm glad we're here together. Actually, timing is right. You know, Bentley Systems, we're a large infrastructure engineering software company, been around for 40 years. And just recently made this acquisition of Cesium. That was on the backs of a lot of testing and sort of seeing the adoption of Cesium in our market, in the architecture, engineering, and construction domain. And this is actually a nice podcast that just went live. That's our CTO, Julian, and Patrick Cozy. And you can check this out. It's really, I just want to make sure this is emphasized as people think about what's it mean when a company like Bentley acquires an open source platform like Cesium. There's a huge commitment here to the openness, open standards. In fact, we're leaning into it like 100%. Patrick Cozy will actually become our chief platform officer for our entire iTwin platform in this commitment to openness. So I think that's a nice testament. We believe in it firmly. It's at the core. And I think bringing Cesium in will just help advance that commitment to open, interoperable standards. So, and yeah, definitely scan that. Check out the podcast with Mark Petit if you want to learn more about that.
Yeah, download it for the flight home maybe. Cool. Okay, so quickly we'll go over the agenda. We're going to be talking about 3D tiles in Cesium, obviously. Jump into some user stories, some really cool examples of how people have used Cesium for Unreal in particular on digital twin and AEC infrastructure projects. We'll wrap up with probably 5 or 6 minutes with some cool tips and tricks, particularly questions that I get asked a lot by users. So hopefully these are things that you can take away and apply to your own projects. And then we'll definitely try and reserve a good amount of time for some Q&A at the end. I'm just going to play a brief video that gives you an overview of Cesium and its relevance to 3D geospatial.
From construction and urban planning to aerospace and defense, modern industries rely on 3D geospatial technology. Cesium is the platform for 3D geospatial, empowering users of all skill levels to build experiences with real-time 3D, massive scale, and geospatial accuracy. At the heart of the platform is 3D Tiles, an OGC community standard created by Cesium to stream massive 3D geospatial datasets like photogrammetry, buildings, and point clouds. We are uniquely dedicated to openness and interoperability. Cesium.js is our open-source 3D visualization engine for the web. Our open-source plugins for Unreal Engine, Unity, and NVIDIA Omniverse allow users to bring real-world data to their immersive apps, experiences, and simulations. To get started, sign up for a free account and upload your data. Cesium Ion will optimize it as 3D tiles and host it in the cloud, or your self-hosted environment. Combine your data with our library of curated 3D global content and start developing. Headquartered in Philadelphia and serving users around the globe, the Cesium platform has millions of downloads and powers thousands of 3D geospatial applications across a wide range of industries. Learn more and sign up today at cesium.com.
Cool. Hopefully that provides you with brief overview. We'll dive a bit deeper into how it relates particularly to digital twins and Unreal. So the foundation of Cesium's platform is 3D tiles. It's an OGC standard for streaming massive 3D geospatial and other geometry datasets into runtime engines. A lot of the content is built on top of GLTF, but it does support other 3D data types. And I guess you kind of think of it as it's doing for 3D what maybe YouTube does for video, right? It's just making it work across the web really well. So why do we need it for digital twins? Well, we could have the world's best architectural model. I don't know if this one is, but it's a model. But kind of, it's useless. Well, not useless, but it only tells part of the story if it's just by itself, right? So we need 3D tiles to help us do this, which is to put the model in context. And what that does is it helps us understand how the proposed design is going to impact the existing environment, right? It's a really important thing when you're working on a project. You need to engage with stakeholders, both internal and external. You need to be able to get that data around. Like I said, I've been working in this space for quite a while, and before Cesium, if anyone's done this as well, real pain to get this sort of massive data into a runtime engine and get it running well, right? You're talking maybe photogrammetry that's gigabytes or terabytes in size, or trying to wrangle with geospatial elevation and imagery and create terrains and get them into something like Unreal running, especially for big projects. It's tricky. And for me, like 3D tiles was a game changer when delivering these sorts of projects. So let's talk about what that actually looks like in terms of Unreal. So here we've got Google's photorealistic 3D tiles, and we're in the Unreal Editor viewport, and we're zooming in from the globe down to San Francisco and back up. And we've got a debug mode on there, which colors all of the individual tiles differently so you can see them. Basically what's happening is as we move closer, the lower detail tiles are subdividing and refining into high detail, and then higher detail and higher detail. And it's kind of limitless really as to how far you can go. It depends on the quality of the data. What that means is it helps us do a few things. Firstly, we're not downloading one massive data set. Google's got something like 2,000 cities modeled in high detail in this. You could imagine if that was just one big data set, you can't use it. So by splitting it up, what it's doing is it's only grabbing the pieces of data, textures, the triangles that we need for the viewpoint at any one time. That's basically allows us to stream it across the web, networks and things like that. If we jump to the same video on wireframe, you'll see how that really impacts the number of triangles that are rendered on the screen. Right? It's basically managing our level of detail for us. So we can still get a high fidelity city, but if we want to go a little bit higher, it's not as detailed. If we want to go further back again, it reduces. And that helps us manage our triangle counts, our draw calls, our texture usage, and things like that. That's really the key philosophy behind 3D tiles and what makes it able to stream these massive data sets in at runtime in a really fast way. So key use case, geospatial context, right? You've got a road, you've got an architectural model, you've got a facility. You want to get data surrounding it. So 3D tiles can help you stream in photogrammetry like we saw, terrain with imagery overlaid, point clouds even. All of these data sets are really good for adding context to your project. But it's not just for geospatial context. 3D tiles is also really great for design data. So think a complex architectural model. If it's organized into 3D tiles correctly, what that means is those detailed nuts and bolts and fittings and pipes, you'll only get them when you zoom in close and need them. If you're viewing the building from outside further away, they're not going to bother loading. And that really helps you run those models, and we'll dive into that a little bit more detail. And I know Greg's presentation in particular focuses on design data quite a bit. So let's talk about the Cesium platform just quickly. There's two main components. There's Cesium Ion, which is our SaaS, cloud, or self-hosted solution. And what that does is it hosts 3D tiles. It lets you upload various types of data and turn them into 3D tiles. And it also provides a number of curated 3D global and isolated content data sets that you can use directly. So Cesium World Terrain is built from various open terrain and imagery sources. It provides access to Google's photorealistic 3D tiles, Microsoft's Bing Map imagery overlays, OpenStreetMap derived buildings, and a whole bunch of others. So you can really get started quickly without having to invest in capturing or procuring data independently. The second component on the right-hand side are our runtimes. So it all started with Cesium.js. This allows you to stream 3D tiles into a globe in your browser in whatever web application you build. And then also our runtimes for game engines and simulations. So Cesium for Unreal, which we'll talk about today, Cesium for Unity, and Cesium for Omniverse. I think Cesium for Godot has just been funded as well, which is awesome. We love to see more 3D tile support in different engines and applications. Okay, so what does that look like for data and your types of projects with this platform? The top left, we've got our context data. We might want to upload terrain, imagery, photogrammetry point clouds. They can all be sent into Cesium Ion through the standard formats like LAS or GeoTIFF, things like that, turned into 3D tiles, stream into the Unreal Engine with the Cesium for Unreal plugin. You might also put some of your design data in there. Could just be 3D mesh like GLTF, OBJ, FBX, or Revit, IFC, other formats like that. Again, they can be turned into 3D tiles, stream into the Unreal Engine. But you don't need to just use Cesium Ion and 3D tiles for this. We know that digital twins are going to have data sources from a ton of different places. So typically you'll find a project is made up of lots of different sources. So the top right there, we might have an architectural model from Datasmith, which has been brought into Cesium Unreal and placed at the correct location on the globe. And now because we've built a geospatial application, we know where on the Earth this data sits. We can connect into location services or IoT or anything that's got information about the globe. So we start to be able to create these really compelling and immersive experiences with all the data sets that are available to us. So I mentioned before, 3D tiles have some pretty great performance benefits. You'll see here we've got a building here which is streaming in via 3D tiles, and I've slowed it down a bit, but basically you'll see the larger pieces streaming in first and the smaller pieces like the furniture streaming in later on. That's obviously giving us greater performance because we're not always rendering all the data at once depending on our view. It also gives us the benefit of less manual effort when working with our data. So if anyone's used an architectural model from Revit, you've probably spent some time cleaning it up, either optimizing things or deleting unnecessary layers and things like that. Because 3D tiles helps you manage when that content loads, you can spend less time cleaning your data, which means faster turnaround times for these projects, which usually don't have Grand Theft Auto 6 level of development time, right? It's quick. When you've got your data in 3D tiles as well, interoperability is a huge benefit. So you might have invested in a pipeline to get your data in. Now that it's in 3D tiles for your project, you could also send it to a Cesium.js based app and create a web experience for it. Or it could even be as simple as, hey, the project team is using something like ArcGIS Pro. They can load those 3D tiles directly in just as part of their daily workflow, or any application that supports 3D tiles. So there's some really good benefits in using that workflow for your data and getting it into lots of different platforms. Okay, easier deployments. I'll touch on these quickly. We're storing less geometry in our builds. Our builds are smaller. That's pretty good. Faster updates is another one that's really helped me in the past. If I'm using something like Unreal and I need to update the content, I'm either redistributing a new build to the client, or I'm creating pack files and patches and things like that, just sending more data in. If you engineer your app correctly, you could get your app to point to an updated version of the 3D tiles for your design. And the next time the client opens it, it'll just stream in, right? So there's less of that deployment process that typically happens on these sorts of things. And data security is another great one. You're not shipping potentially sensitive design data with your project. It's only streaming at runtime. So you've got the ability to kind of control who can access it and when. If you do need to switch it off, you don't need to worry about apps being out in the wild with access to that data. And if you use something like Cesium Ion self-hosted, you can control where that data sits across the end-to-end lifecycle. So I know these projects usually have some fairly strict data requirements. It lets you either put that in your private cloud or the client's private cloud and control who can access it and when. So get started, pretty straightforward. Grab the plugin from the marketplace. Also our GitHub to get the latest builds. We've got sample scenes. It's very easy to use. Open up the samples, start playing around, modify them. Cool. So let's jump into some user stories. First one, we're going to talk about Pannoni. So they're an engineering firm. It's been doing visualizations of their design for, I think it's about 2015. They began using Cesium for Unreal last year, I think particularly in combination with Google making their data available. And they're deploying it now on multiple projects. So this one here is a bridge protection system project. So you might see down the bottom those little cylinders that protect the base of the bridge. What Pannoni's done is they've taken the as-built data from this bridge, they've taken the design data for the dolphin protection system, and they've added it inside of Google's photorealistic 3D tiles. So basically what they've got is a digital twin for visualization. They can produce imagery and video super quickly with this project setup, and they haven't had to invest in a whole lot of time to capture or create that spatial context. So the client might quickly request a view from the other side of the river there. They can just fly their camera down there, capture it, produce a video. In fact, this video, I asked them if they could flick me something earlier this week. They had it out within a day or two, so really fast turnaround times for these sorts of projects. The next one from Pannoni is a set of proposed condominiums. Same sort of story. What they've done is they've taken the design data for these buildings. They've cleaned them up, modeled them up, got them to the level of detail that they want, and they've added them amongst Google's photorealistic tiles. And they've added some additional high-res assets in the immediate foreground there. You can see those trees. And again, similar story, it allows them to create really quick and fast turnaround visualizations without the effort that would be required to produce all of that context. And that gives them a ton of flexibility with budget and time on their projects. Now jump to Spatial Media. Spatial Media is an Australian visualization studio, and they have a platform called Spatial Reality. So this is really focused around creating interactive experiences for stakeholder engagement, particularly for built environment projects. And this one's pretty cool. So this is a project they did for John Holland Group. It's an extension of the Gold Coast Light Rail tram network, so it's about 7 kilometres long. And you'll see here what they've done is they've taken the proposed design for the rail network, the light rail, and they've ingested it in amongst Google's photorealistic 3D tiles. They've added quite a good level of polish with animated trams, cars, people, and a bunch of features that allow users to get inside the tram, view it from the tram ride, jump down to different locations, and things like that. They've also added a number of tools in here, things like measurement tools, so that when they're in a conversation with the client, they can quickly measure different areas without having to go back to the design data or the plans or open up other applications. They also have adjustable time of day so that you can test out different shadows. All of the shadows are accurately positioned based on the location on Earth and the time of day and the month that they're using. And they've added in some additional weather effects and things like that too. They've also added in the ability for users to jump to predefined locations so you can navigate around the model quite quickly. Again, these are usually non-technical users. And then they've even hooked it up to geocoding APIs so that users can search for particular locations, highlight them, and fly to them. The last thing they've got in here is the ability to create really easy fly-through orbit type videos and imagery and things like that. So here we're seeing them drop down an orbit camera. They can start playback very quickly, record that to a video, upload that to Spatial Media's web API, and then share that with their users. So this is kind of the day-to-day use case for John Holland. They use it to have conversations with their stakeholders. They also use it to produce media content for socials and things like that without needing to go back to the consultant every single time just to produce some small videos like this. So pretty cool project. Okay, I'll hand over Greg. So as Greg mentioned, Bentley have been using 3D tiles and Cesium for quite some time. And I think this is going to be a really cool example of how our open source plugins can be taken and adapted and tweaked for different use cases. So I won't steal the thunder.
Okay.
Go ahead. You want that?
Thank you. So yeah, we're actually consumers ourselves of the Cesium tile set. And similar to the use cases we just saw that Ryan showed, we have a lot of customers who are interested in taking their engineering models from MicroStation, from Revit, from Navisworks into our platform, which is called the iTwin platform. And so that works today to view these models in a web viewer, but you don't get that level of high fidelity graphics. So the question was, how can we get those detailed engineering models into a geospatial context and render it and have real-time interaction with Unreal Engine? So that is where we started our focus, and we built a plugin for Unreal Engine based on top of Cesium, but what it does, it makes a live connection to the iTwin platform, our Bentley platform for infrastructure engineering data. And to serve two purposes. One, to put this out in GitHub so developers can build their own custom software development with this plugin and not be restricted to just what they get out of our web viewer. And two, I'm going to show you that we're actually now trying to eat our own dog food, build an app ourselves, a Bentley branded app on top of this plugin, and bring that to market as a low-code, zero-code interaction. But we want to support both, right? An open ecosystem and then our own custom app. iTwin, our platform, does have APIs, so our users, right, engineering firms, architecture firms, owners, ingest, synchronize their models into the iTwin platform. That includes photogrammetry, BIM data, and we've also got APIs for construction simulation, what's called 4D animation, through a product we own called Synchro. And we've added additional API layers to decorate the scene with things like plants, trees, equipment. We can store and transmit views between sessions, capture and place issues, and also pull metadata down through the BIM and CAD information. The plugin, let's see if that's running. I won't show this slide. This is running in 5.3. We haven't ported to 5.4 yet. Nothing out of the usual here. It's just a plugin. iTwin plugin goes in and creates an iModel actor. The iModel actor will then take IDs, iTwin IDs, that then you authenticate with yourself as a user. And then you can go fetch and retrieve your iModels. And then using Cesium, we automatically have a script that generates the 3D tiles on the back end and then stream them down into Editor. It also works at runtime if you publish an app, and I'll show you that in a second. So that's the model coming and just streaming and sort of hydrating, in Editor. And then once you're in Unreal Engine, then sky's the limit. You can start to augment that scene and do what you want. This is a nice example. This is a customer that we're working with, Balfour Beatty Vinci construction company, delivering a project in the UK called HS2. It's a large linear railway going from Birmingham to London. This is a really nice example of that custom application development where they're using our iTwin plugin and the Google 3D tiles from Cesium to create this geospatial context for the railway. So all the rail that you're seeing is a series of like dozens and dozens of engineering models from MicroStation that have been synchronized into our iTwin platform and then streaming down into this application. So it's not just a video, this is a recording of actual gameplay through the app. And you can see because it's custom app development, they've added additional things to kind of render a bit of like indication of traffic and patterns. But I think this is where it gets really interesting. Also linking to asset information on the back end. So they've got an entire asset management system. So as you click on each object in the rail, you can go and actually pull and extract metadata about that asset, and then navigate throughout the entire railway. Again, what I think this is cool, the thing about the Cesium, it's the first time that really you can experience the scale of a system like this just automatically and dynamically with minimum effort. So that's a really nice example of a custom app development that we're seeing. Now, we're also building our own app, a Bentley branded app, and here's a couple screenshots, videos of what we're developing here. Which is, again, a no-code app. It's an executable. You can launch the app, link to your iTwins, start to augment the scene with entourage, characters, trees, plants, create camera views, save those views back to the server, and then share that application with other stakeholders. So it'd be a way to just like log into this app and have access to your content like that very quickly. And here you can see we've directly integrated, by the way, the Google 3D photorealistic tiles. It's literally now in this app, just a toggle switch, and it just turns it on and off. So no need to kind of go and do some extra work back in Editor. Another thing we've added, you can see this timeline at the bottom there, is it can read the 4D construction data from our Synchro platform, and now you can actually scrub through the construction animation to see how the sequence will play out. So that was actually a nice innovation that we had to come up with Cesium, is not just load the static mesh, but how do you render that mesh, those Cesium tiles, according to a construction sequence. So things appear and disappear according to the schedule. So animation. I don't know if I want to show the live demo now, or people can scan this to get in, but I think this is a good place to start. The iTwin plugin is up on GitHub. If you scan that, you can get going straight away, plug it into Unreal Engine. It is just for 5.3 at the moment. There we go, okay. Yep, okay. So this is an example of a rail project in Jakarta, just one of our customer models we got permission to show today. We have just dozens and dozens of these models, but all of this is showing up. This is the BIM model from the iTwin platform, and then you got the Google 3D tiles streaming in around it. And then with the saved views API, we can create these camera transitions automatically. So if we like a different shot from, say, here, we can just create a new viewpoint, and hopefully that will work. Yep. And so what's interesting about that, it's every time we snap these camera views, it's actually storing it back to the server live. So if another user actually launches into this application, that view will appear in their session as well. So it's all API driven rather than like a file-based workflow. And if I go back to the Google 3D tiles, you can see here we've got this as just a toggle switch. So in this app, you won't need to have a special subscription to Google in order to have access to those Cesium 3D tiles. I think that's quite a nice feature. And in terms of the eye model itself, you can see that's that model. And we'll have the ability to bring in as many of these models as you want. You have architecture, MEP, structure as different like layers of streaming content that you could toggle on and off in addition to the geospatial terrain. Yeah, and then typical things like you might expect: control over the environmental settings, fog density, to play with the sort of the effects you get out of Unreal Engine ultimately to create those effects. And the idea here is make it, again, easy to access, zero code, just get people right into the experience as a way to experience these BIM models and large infrastructure projects. And then lastly, and then for the demo, we've also added the ability to bring content into the scene to start to augment the scene with people and maybe like a car, a Chevy, so this type of thing. So nothing unfamiliar to like anyone using Unreal Engine, but for a lot of our users, even having access to this level of simple interaction without having to be a UE developer, I think is super, super valuable for our users. So that's a sneak peek. This is in early access. We haven't released this officially, but it's all part of this coming together of Bentley and Cesium to kind of really bring a product to market that people can take advantage of just the sheer power that 3D tiles brings to all this. So yeah, everything you're seeing here is running at runtime with the power of those 3D tiles. Yeah, so that's a bit of a live demo, and looking for that. We'll be announcing this next week, and also with another early access program if people are interested in joining that, or you can contact me at any point afterwards. All right, cool.
Awesome.
That's it.
Thanks, Greg.
The live demo.
That's really cool. I mean, the fact that you could have a new design for this site, upload that to iTwin, stream it straight in without having to touch it, produce a new build is pretty powerful in these sorts of projects where designs often change daily,
Up and change.
hourly.
Yep.
And someone calls up and says, we've got an announcement with the planning minister tomorrow morning. Can you please produce an updated output? That's totally a game changer for
And
that
that just connects to the latest revision, exactly.
Very cool. Okay. So hopefully there's been a bit of inspiration there in some of those projects. They're pretty cool. We love to talk about our users and what they're doing. So if anyone is working on something really cool with Cesium and Unreal or any other platform, please reach out. We'd love to produce blog posts and socials and things like that. What I'm going to do is run through some tips and tricks for a couple of minutes, and then it should give us plenty of time for some Q&A. So the first couple of tricks will be PowerPoint ones, not how to use it. Don't ask me. Okay, the first couple of tips. Check out our, we've got a couple of programs we run for the community. Our Cesium Certified Developer Program is really cool. If you're a Cesium user or you're interested in being a Cesium user, you can become a Cesium Certified Developer. And that will help train you in various aspects of Cesium. It also puts you in kind of like a network where then people who are looking for developers familiar with Cesium can go and find people to collaborate with and work with. So check that out on our website. And the other one is our ecosystems grants. So Cesium for Unreal, I'm sure you're all familiar with the Epic Mega Grants, right? That's kind of what sparked Cesium for Unreal. And we have a similar program now where we're looking for any cool ideas that are related to 3D geospatial, to be honest. They don't necessarily need to use Cesium. So check out the Ecosystem Grants program as well, because there's some pretty cool stuff going on in that space. Now, one tip, Twinmotion doesn't support 3D tiles. Hopefully it does one day. But you can still get geospatial context into Twinmotion. This won't be a tutorial, but just an FYI. Cesium Ion, which is our cloud platform, has the ability to clip out portions of 3D tile sets. Not all, it depends on the terms and conditions of those tile sets. So for instance, you can't do it with Google's, unfortunately. But what I'm showing here, let's make it play again, is I'm in Cesium Ion. I've drawn a site boundary for my project. I've exported that out as GLTF from the original 3D tiles. And then I've been able to bring that into Twinmotion and sit that around my site. So at least I've got some level of context there. If you set up the site correctly with the right latitude and longitude coordinates and you know where your site is positioned, you should be able to make that snap into place as well to avoid the kind of eyeballing that you sometimes need to do when placing these buildings on a terrain. And the other thing with Twinmotion as well, you might have seen in some of the other talks, there's a cool workflow that brings your data from Twinmotion into Unreal. So if you did have a Twinmotion project that you wanted to integrate 3D tiles with, you can always bring it into Unreal through Datasmith and then add the Cesium for Unreal plugin and start streaming your data in alongside it. So a couple of things to think about there. My next ones, I'm going to flick to the editor. Okay, cool. So the first one here in the editor, I just wanted to talk quickly about clipping out terrain. It's a very common question. I've got Google's data, I've got Cesium World Terrain. How do I get rid of the existing conditions to replace it with my own? So for those who don't know, we have an actor called a Cesium cartographic polygon. It's built on top of the editor's spline. Basically, you define a shape, you link that shape up to your 3D tile set and tell it cut a hole here. So very common workflow. There's tutorials on our website, but just that's a thing that can be done because we do get a lot of questions about that one. And, you know, it lets you fill your design in that space without clashes, which is obviously pretty important. The next one that you should know about are globe anchors. Oh, here we are, Convention Center. So pretty common request once you've got a globe that you want to attach something to it. With Cesium for Unreal, what you can do is you can move the globe around. You can fly to different latitude and longitude coordinates. You can move it up and down. Let's just try to make the UI work. There we go. Oh, it doesn't like that. We can scale the Earth. So I think VR or tabletop. What you want is you want to be able to pin your non-3D tiles actors to the globe. So you'll see here, this marker is still just floating where it was, whereas this marker has shrunk down and is still in the right position. And that's because it's got a Cesium globe anchor component added to it. So check out globe anchors, really useful for a lot of things. Obviously, pinning something onto the Earth is the key use case, but it's also really good because you can define a latitude and longitude for this actor, and it will automatically convert that into Unreal coordinates, right? So let's say you were connected to a mapping API and you received a bunch of points of interest, you want to drop down some markers, you can add globe anchors to those markers and just punch in the latitude and longitude and they'll snap into the right spot. So check those out. Okay, let's play this one. So 3D tiles, one of the cool things about 3D tiles is they support metadata. And let me just full screen it. So what we have here is a project. Everything on the screen is 3D tiles, right? There's no standard geometry, there's no static meshes. And what we want to be able to do is click on these different components, which has come from Autodesk Revit. This is their standard sample model. And we want to access the metadata that sits behind these. Now, I can click on each of these individual objects and get that metadata, but what they are not is they're not individual actors inside of Unreal. So we don't have 5 million different components sitting there slowing things down. So everything's still taking the benefit of batching and reduced draw calls and things like that with 3D tiles, but we still have a way to be able to raycast onto a surface and retrieve that metadata. So it's a really cool use case that you'll see, I think, become more and more relevant as you start to look at pushing design data with this sort of metadata into 3D tiles. And then on the topic of metadata, just check this one out quickly. Okay, so metadata in 3D tiles can also be passed through to materials, which means it opens up some pretty cool shading opportunities, right? So here I've got this example where I've got some piping, and each of these pieces of pipe, or most of them at least, have a length metadata attribute. Now that can be passed to the shader as a float or an int or typical sorts of things you get into a shader. And then I've written a custom shader and hooked it up to some UI that lets me change min and max values, so I'm highlighting pipes that fall within that range. So you can start to create some pretty cool effects without needing to, again, have thousands of separate actors that you need to query separately and things like that. You could also use this to, say, show and hide different components of your 3D tiles. So like hide all the windows or hide all the stairs, as long as they have, kind of like a category piece of metadata, which you get from Revit. You can do that without needing to split your data set up into these separate layers manually and toggle them on and off. Okay, this one we get asked about quite a bit too. Okay, so architectural models, pretty all right for placing onto the Earth. Big linear infrastructure, well, if you've ever worked with design data from CAD, it appears that we still seem to think the Earth is flat, and that data is not curved to the Earth, which I get it, that's how you need to work in those design packages. But obviously when we want to be able to render and mix that data with something like a geospatial data set like this, we need a way of being able to curve that design to match the Earth accurately. So what I've got here is a sort of like 11 kilometer long road alignment. And you'll see I've got a green surface fighting with a yellow surface. So the yellow surface is an IFC that's still in its flat projection. The green surface is the same data that's been reprojected to the Earth. And I've aligned them so that at this very point here, they're matching perfectly, right? They're at the exact same lat long. And just to show how much of a difference this reprojection can make, as we start to fly along the alignment, we're only a handful of kilometers, if that, along, and you can already see they're starting to diverge quite substantially. We get to this point here, and you'll see that the tunnel is like meters out, right? So if you're trying to produce a credible, accurate digital twin or simulation that people are going to use to make decisions, kind of doesn't really work, right? Your data's in the wrong spot compared to the context. And then if we fly, it's a big project, and check out the cool cutting spline. So all of this stuff is actually got a very complex shape that cuts into the terrain so that it doesn't clash. Lots of cut and fill on this project. We can fly all the way to the end. We're about 11 kilometers now from the start. Look at that. It's like 10 meters difference in elevation and probably about 10 meters horizontally as well. So what you can do with our tiling pipelines, they're hooked up to geospatial libraries. So if you push in an IFC and say this is in a specific UTM coordinate system that the project's using, and I want it to turn into the ECEF coordinate system that Google's photorealistic 3D tiles use, or Cesium world terrain, our tilers can take care of that. And when you get your 3D tiles out of that process, they'll match the terrain perfectly like this. You can see that road is where it's meant to be, right? So keep that in mind for big projects. It's definitely kind of important. And then the last one, before we wrap up, let's fire this one up. So I mentioned we can support point clouds, which are loading in here. The point I want to make with this one is check out open data sources, right? Lots of local, state, federal governments have various spatial data libraries that are free and accessible in standard formats like WMS or WMTS. They have point clouds, sorted LAS files, things like that. You can take those data sets and add them as additional layers to your project for minimal effort. So for instance, these point clouds, I downloaded a bunch of LAS files off of this particular government's website, uploaded them into Cesium Ion. They stream straight in. They still retain their classification, intensity, RGB type values, which I can use in the shaders. And just add some extra data for these projects that you might want to flick on and off depending on what sort of question your stakeholders might have. It can be used just as a verification layer. Does this data set match that data set? It's a really powerful thing to use. And then the other one, if I just turn off the point clouds, okay, what I've got here is a WMS server overlay, again from an open government data source of land use planning. So the different colors represent different types of land use. You can add a component to any tile set and connect it to a WMS or a WMTS server and stream that data straight in. You don't have to take it, process it, you don't have to upload it to Cesium Ion, you don't have to do anything with it. It'll just connect straight to that data source and stream in. And again, really cool, basically freebie, right? It's like 5 clicks to get sorted. Have it as a layer in your project, and it can add some credibility, it can be useful. The other thing to think of is if you're working on a project like this, there's probably a geospatial team working on it, probably already has a bunch of layers that relate to the project that you could also stream in through this process. All right, so check that out as well, super powerful. Now I think, flip through my backups. Cool, okay. So that wraps up the tips and tricks. I guess the last one is go check out our website. That QR code should take us to our learning center. We've got tons of tutorials there. We've got links to our samples and things like that. So if you want to get started, learn some new things, jump on the website and check it out. I think that pretty much wraps it up. So I'll leave that up there for a bit, but happy for any questions.